Good morning everyone. Today we are going to discuss about graphical representation of motion. Why we have to study about graphs? You know, graphs can be used to visually illustrate complicated data and is used in various fields like business, sports, scientific calculations and etc. Many purposes we are using graphs. So, today we are going to study about motion graphs. So, what are the objectives? So, we can go to the objectives. You know, objectives. Understand and plot displacement time and velocity time graphs for uniformly accelerated motion. And identify and use physical quantities derived from the gradient and areas of displacement time graph and velocity time graph. Means today we are going to study about displacement time graph and velocity time graph and what are the quantities we can derive from displacement time graph and velocity time graph. Before going to our graphical representation of motion or motion graph, we have to know about basic idea about graphs. So first of all, the gradient. What is mean by gradient? Gradient represent how steep a graph is. The steepness of the graph is gradient. The other name of gradient is slope, and it is calculated by using the equation delta y divided by delta x. Delta y represent the vertical change and delta x represent the horizontal change. So the equation to find gradient is delta y divided by delta x, or gradient is equal to y2 minus y1 divided by x2 minus x1. From this graph, you can see vertical axis is y-axis and x-axis is marked, and the red line represent the graph. And two coordinates are plotted, x1, y1 and x2, y2. So once we mark the 2 points or two coordinates, easily we can identify x1 value, y1 value, x2 value and y2 value. We can take it from the axis, and after that we can use the equation gradient is equal to y2 minus y1 divided by x2 minus x1. So this is how we will find the gradient. So the equation to find gradient is equal to y2 minus y1 divided by x2 minus x1. So this is how we will find or we will calculate the gradient. Now we can study about different gradient graphs. So the first one is zero gradient graph. You can see the graph. The horizontal line, the blue line represent the graph. This blue line graph is a zero gradient graph. Horizontal line is always zero gradient. Why? Because we know the gradient equation is delta y over delta x, vertical change divided by horizontal change. So for this graph, when we observe this graph, we can't see any change in y-axis, which means that delta y is equal to 0. If delta y is equal to 0, if delta y is 0, then the gradient will be 0. So this is a zero gradient graph. So please remember, the horizontal line means it's a zero gradient. Then the second type of graph is positive gradient. So this graph represent a positive gradient graph. Then the green line, you can see the green line, that is the graph, and we can just find the gradient of this graph. So the gradient equation is delta y over delta x or y2 minus y1 divided by x2 minus x1. Here, two coordinates are plotted. First one is 2, 1 and second one is 4, 5. So when we calculate the gradient of this graph, delta y is equal to 4 and delta x is equal to 2. So what will be the gradient? 4 divided by 2, which is equal to plus 2, which means that this type of graph represent positive gradient. So this is what a positive gradient graph looks like. The next graph is negative gradient graph. So you look at the line, the graph you can see, and they are plotted 3 points. They plotted 3 coordinates. They plotted. So we can consider any 2 points. Example 0, 3 and 1, 1. The first point is 0, 3 and second coordinate is 1, 1. So when we calculate the gradient of this graph, we will get y2 minus y1, that is delta y, which is 1 minus 3. So 1 minus 3 is equal to minus 2. So delta y is equal to minus 2 and delta x 1 minus 0. 1 minus 0 means that is 1. So delta y is negative in this case. So delta y over delta x is a negative value. In this case minus 2 divided by 1. So gradient is minus 2. So if the graph is like this, so the gradient is negative. So there are three graphs according to the gradient we said: zero gradient, horizontal line, and positive gradient and negative gradient. So these are the three graphs. And we can go to, according to the gradient, we can see many type of graphs. So we can just go and discuss about the next types of graphs. According to this, we can conclude with this. So here we already studied what is different graphs represent. So first one is gradient 0. Yeah, that is a horizontal line. Horizontal line means the gradient is 0. Second one, gradient is positive. Yeah, it's a positive gradient graph and there is no change. It's not a curve, it's a straight line, which means that gradient is constant. Then third graph, gradient is negative. Yes, it's a negative gradient graph. And it's a constant. It's a straight line. Straight line means gradient will be constant. Fourth one, the gradient is positive. Yeah, it's moving up. So gradient is positive. And gradient is increasing, which means that at the beginning the gradient, the slope is less, then if it is, when it is moving up, the slope is increasing, which means that the gradient is increasing. So remember, the fourth graph, gradient is positive and the gradient is increasing. Then fifth one, gradient is positive. Yeah, it's moving up. If it is moving up, it is positive. Gradient is positive and it is decreasing. Let's see. At the beginning, the gradient, the steepness is, the slope is high. Then the slope is decreasing when it is moving up, which means that the slope is decreasing, meaning gradient is decreasing. So the fifth graph represent gradient is positive and the gradient decreases. Then next, sixth one, gradient is negative. Yeah, because it is moving down. If any graphs moving down means gradient is negative. And what about the slope? At the beginning it is very high, then when it is moving down, the gradient is decreasing. So we can conclude that gradient is negative and decreasing. Then the last graph gradient is negative. Obviously, the graph is going down, which means that gradient is negative, and initially the slope is less. When it is moving down, the slope is increasing. So we can say the gradient increasing. We can conclude for the last graph gradient is negative and increasing. So these are the basic things you have to remember before we are going to our motion graphs, displacement time graph and velocity time graph. We will discuss later. So now the basic concept you have to remember. The first of all, the first thing you have to remember, um, the gradient equation. Gradient means gradient represent the steepness. The equation y2 minus y1 divided by x2 minus x1 means delta y divided by delta x, and positive gradient is there, zero gradient is there, negative gradient is there, and gradient can increase or decrease. So these are the basic things you have to remember before going to the graphical representation of motion. So now we can study displacement time graph. Now we can discuss about displacement time graph. So in displacement time graph, displacement we will plot on y-axis and time we plot on x-axis. Displacement is a dependent quantity and time is an independent quantity, which means that the displacement changes with time. The main important point you have to remember to explain displacement time graph is the gradient of displacement time graph is velocity. So once again, please remember all the displacement time graphs we can explain by using this simple concept, that is gradient of displacement time graph is velocity. So let's see, we can explain different displacement time graph by using this concept. So let's see. So here there are three graphs given A, B, C. So we can just explain the first graph A. So for the first graph, displacement time graph, the gradient is 0, which means that velocity is 0, which means the first graph represent the object is at rest. Means velocity is 0 means the object is at rest, the object is not moving. Then second graph. For the second graph, the gradient is positive, means there is a gradient and it's a straight line, which means that that is a constant. So here gradient is constant and there is a gradient constant and positive, which means that velocity is constant and positive, which represent the object is in uniform motion. If an object is in uniform motion, the velocity is constant. So we can explain the second graph by using that. The third graph, third displacement time graph, here the gradient is positive, which means that there will be a positive velocity. And initially the gradient is less and gradient is increasing when it is moving up, which means that velocity is less at the beginning, the velocity is increasing. So it represents acceleration. So the first graph represent rest, second graph represent uniform motion, and third graph represent acceleration. So for deceleration graph, how it will be then? For deceleration graph, there will be a positive gradient, but initially the gradient is high, then gradient will be decreasing. So other way around, compared to C. Now, so these are the main points you have to remember about displacement time graph. So what are the summary? We can conclude displacement time graph now. What are the important point you have to remember about displacement time graph? The first point and very important point, the gradient is equal to velocity. Yeah. Then constant velocity is explained by the straight line while acceleration is explained by the curved lines. Positive gradient means the motion is in the positive direction. Negative gradient. In displacement time graph, if you see anywhere a negative gradient, which means that the object is moving in opposite direction. So negative gradient means the motion is in the negative direction, means the object is moving back. And zero gradient. In displacement time graph, if you see a zero gradient, that represent the object is at rest. So these are the main key point you have to remember about displacement time graph. Now, next, how we can calculate velocity from displacement time graph. Calculation of velocity from displacement time graph. You know, you will get a various type of displacement time graph. Sometimes it might be a straight line or sometimes it might be a curved line. We know the velocity is the gradient of displacement time graph. So the equation for gradient can be used to find the velocity. So the velocity equation, delta s divided by delta t. Delta s is change in displacement, delta t is change in time. In other words, in terms of gradient term, what we can say, y2 minus y1 divided by x2 minus x1, or delta y divided by delta x. So here, how we can find delta s and delta t? If it is a straight line graph, just plot two coordinate and make a triangle and find delta s and delta t as shown in figure. And if it is a curved line, for curved line, the question they clearly say what will be the velocity at particular point, which means instantaneous velocity they will ask. So you just put a point on that time and draw a tangent as shown in figure. So then if you get a tangent, it's a straight line. From the straight line, just make a triangle and find delta s and delta t and find the velocity. So velocity is equal to delta s over delta t we can use. So which means that the calculation of velocity from displacement time graph is exactly you have to find the gradient. If you find the gradient, you will get the velocity. Remember, the unit of velocity is meter per second. So now we are going to study the next graph, velocity time graph. So velocity time graph. In velocity time graph, we will plot velocity on y-axis, time on x-axis. Same like velocity is a dependent variable and time is an independent variable. And the important concept about the velocity time graph is the gradient of velocity time graph is acceleration. So by using this concept, we can explain all velocity time graph. If you get any number of velocity time graph, you can explain the motion. They explain the motion of an object by using this simple concept. Gradient of velocity time graph is acceleration. So we can just discuss various velocity time graph now. Now, the first graph represent rest. How we can say that that graph represent rest? So we can see the the graph drawn on the x-axis, which means that velocity is equal to 0. Velocity is 0 means the object is not moving, so it will represent rest. Second, Second, they said uniform motion. Uniform motion means velocity is constant and there is no acceleration. So let's see. Here, the gradient is 0. Gradient 0 means acceleration is 0. And velocity throughout the time, the same velocity, which means that velocity is constant and there is no gradient, means there is no acceleration, which means that that graph, the second graph, represent uniform motion. Now the third one, C, uniform acceleration. So here uniform acceleration means there will be an acceleration and that acceleration is constant. How we can say that from this graph? We can see that the graph represent there is a positive gradient. Positive gradient means there will be an acceleration. And this it's a straight line. Straight line represent gradient is constant, means acceleration is constant. So the C graph represent gradient is positive and constant, means acceleration is positive and constant. So it's a uniform acceleration. The next, the D, uniform deceleration. Deceleration means acceleration is negative and it is constant. So uniform deceleration means there is a negative acceleration and a constant value. So we can see, look at the graph, velocity time graph. Here the gradient is negative. Gradient negative means deceleration, means negative acceleration, that is deceleration. And it's a straight line means constant, gradient is constant, means it's uniform deceleration. Then the next graph, E, non-uniform acceleration. What is non-uniform acceleration? Non-uniform acceleration means the last two, means E and F, both represent non-uniform acceleration. E also non-uniform acceleration, F also non-uniform acceleration. So first of all, what is the difference then? Why this much difference? Same thing, what is the difference? Let's see. The first one, both gradient is positive. For both gradient is positive, which means that both are acceleration. Then here the acceleration, the gradient is less, the gradient is less at the beginning and the gradient is increasing, which means that acceleration is less and acceleration is increasing. So the E graph is non-uniform acceleration and acceleration is increasing. Then F, it's still acceleration, but the acceleration is greater at the beginning and the acceleration is decreasing, which means that it's non-uniform acceleration, but acceleration is decreasing. And there are G and H, but we are not discussing here. So that is non-uniform deceleration, deceleration increases, non-uniform deceleration, deceleration decreases. There are two cases are there that we are not going that much. So here these 2 points you have to remember: non-uniform acceleration, non-uniform acceleration, acceleration decreases. So these are the different types of graphs we have to remember. Okay, So next, so always when we know the basic concept about the gradient and what is the gradient and what is area under the graph and those things, if we know the basic concept, it is very easy to understand the graph. And by doing this we can say the motion of an object, what kind of motion, that we can explain very easily. Now, what are the main points we have to remember about velocity time graph? What are things we have to keep in our mind? So, the first one, the gradient is equal to the acceleration. Yeah, the gradient is equal to the acceleration. Steep slope or gradient represent the rapid change in velocity. Means there is a sudden steep. If the graph is steep, means the steep, there is a steep gradient or slope is there, means there is a rapid change in velocity. Shallow slope or gradient represent the slow change in velocity. Then if the gradient is negative, then the acceleration will also be negative, which means that deceleration. Then if the gradient is positive, then the acceleration will also be positive, means there will be an acceleration, velocity increase. And very important thing, the area under the velocity time graph represent the displacement of the object. So there will be different shapes you can see, sometimes triangle. So the area of triangle, you can find the displacement. So the area under the area under velocity time graph is displacement. So please remember that. So here, so these are the important points you have to remember about the graphs. Okay, so what are things we discussed today? We discussed about gradient, displacement time graph, and velocity time graph. And so please go through all these lessons once again, and we are uploading two assignments, and already we uploaded the notes of all these graphical representation of motion notes we uploaded in this way, and followed by we uploaded two assignments, worksheet on motion graph and motion graph 1 and worksheet on motion graph 2. There are two assignments also we uploaded. So first you complete the assignment 1. I'll give you the deadline. I will communicate the deadline in Viber, and the assignment 2 also we uploaded, so you have to do these two for this week. So thank you.